this video we're going to create a custom inspector for our script along with some custom gizmos. This is excellent for building awesome easy to use tools by making your classes more designer friendly and easier to work with. The inspector shows exactly only what we want, and the gizmos help display extra information right on our scene view. Let's begin! This video is sponsored by AudioMob. AudioMob helps developers monetize their games through non-interrupting audio ads. You can earn more money while having happier players. So instead of intrusive video ads that take up your entire screen, you have audio ads playing in the background whilst the player is enjoying your game. So the player continues having fun while the audio ad plays in the background. You can monetize using standard audio ads that allow the user to skip the advert at any time, or you also have the rewarded type, which allows your player to get rewards by listening to an ad. Players don't enjoy having their games blocked, so it's quite possible that this new unintrusive ad type will become the new standard in the future. It's very easy to integrate into your games via their Unity plugin. Click the link in the description to learn more and start monetizing your games through non-intrusive advertising. Clicking the link also helps support the channel. So lately I've been working on the interactive tutorials for the CodeMonkey Steam app. If you haven't yet, then please click the link in the description to add it to your wishlist. I've been playing around with several possible approaches for teaching the player, and I realized I needed to make a scripting system in order to handle timing and clicks. And since I have to build tons and tons of content, I decided to research how I could make my script very designer friendly to make content building much easier. Alright, so here's what we want to make. There's a script to make a bunch of actions, and tons of awesome gizmos to be able to easily visualize all the scripted events that are happening. Let's see it in action. Here it is, starts off with that character, goes in there, he opens the door, he moves forward, he says something, then this one moves there, he says another thing, then that one goes away, and he closes the nice door. So this is all scripted using very simple actions. So for here, this is the simple script to handle those actions. It has an enum for each action type, and each one is supposed to have different type of parameters. Without the editor script, this is what it looks like. Everything looks very messy. So this one, for example, is an action type of door, but over here I can still see the chat bubble parameters and the move parameters. So ideally, if I pick the door action, that means that all I want to see are the door parameters. And over here on the scene view, all I see is an empty game object. Working like this would be extremely difficult in order to set up all of the scripting logic. I would need to select each individual game object, and here I would have to think about which fields need to be set, so that would make content building very difficult. And here it is with all the editor scripts enabled, and right away you can see that the parameters shown are dependent on the action type. So this is the chat bubble, it only shows me the chat bubble parameters. This one is a move, it only shows me the move parameters, and this one a door, and again only shows the door parameters. So the custom inspector is showing different fields based on the logic of what I have selected in this field. And visually in the scene view, we can also see a bunch of arrows and labels that clearly indicate what each action is doing. So for example, over here I have a move action, and this move action is linked to this unit and is going to move this unit onto this position. Then once it's done, it goes into this action, and you can see that this action is of type open door, and it will open this door right here. Then once it's done, it goes into move, which again is going to move that one onto this position, and so on. Then this one is a chat bubble, so it's going to say this message on top of this unit, and so on. So thanks to all of these gizmos, it's very easy to visualize all of this scripted behavior. Now, like I said, I researched this while working on the CodeMonkey Steam app. Here is a scene with all of its scripted behavior. Now this object has an action of type mask mesh, which is using this object as its mask and leads into this other action. Now I covered the mesh mask in a previous video, so check it out if you want to learn how to make a complex mesh in your UI. Visually, I can clearly see what the scripting is doing. Managing all of this logic without a custom inspector and gizmos would take 10 times longer. So here I will cover how you can make your own custom inspector and gizmos. And this is just one possible example of how I use them to make a tool to make my life easier. Making custom editors is extremely extensible, so you can do whatever you want. For example, having custom gizmos is really helpful if you have some sort of patrolling AI system and you want to drop some waypoint positions. Or visually just to see in your scene view all of the stats for each object in your world. Custom editor scripts are monumentally useful for making all of your tools easy to use and improving your productivity when building content. Then in the next video, we're going to see how we can take this even further by capturing clicks in the scene view to automatically fill our fields. Alright, so this is our goal. Let's get to it. Okay, so here we are in our starting scene. Pretty much just two characters sitting around idle. And here is the editor. Alright, so let's begin by making our underlying script. So we make a new C# script. Let's call this our custom action and open it. Okay, now here we're going to keep things as simple as possible. We're going to make an enum for the action type and have different parameters for each action type. So first we make our public enum. Alright, here it is. So one will spawn a chat bubble and the other one will move a character. Now let's define the parameters for each type. Alright, so here it is. We have classes containing all of the fields that we need to execute our actions. Now, one thing here, in order for our custom classes to show up in the editor, we need to add here the attribute system.serializable. If we don't, then these fields would not show up in the editor. Okay, so here we have all the data required to complete each action. And now that we have all of our action data, let's make a simple function to trigger it. Alright, so there it is. Over here I have a main execute action function, and we just do a switch on the action type. So if we have an action type of chat bubble, we trigger the execute action on the chat bubble params class. So we trigger this one, and if we have a move, we trigger this one. Now the behavior for these particular functions isn't relevant to this video. Here we just want to learn how to make custom inspectors. But if you want to learn more, I also covered these two in previous videos. So the chat bubble is from the chat bubble video. And down here the move action, that's from the modular character controller video. So go ahead, check the links in the description if you want to learn more about how these two were made. In this video, all we care about is learning how to make a custom inspector that we can apply to any scenario we want. And here let me also make just one simple note in terms of code architecture. Here I am keeping it as simple as possible just to demonstrate the effects of a custom inspector, so that's why I'm placing both actions in the same script using an enum. If you'd like to make a custom action script the absolute proper way, that would be by having each action in its own script, probably by using a proper common interface. So here I want to stay focused just on the editor script, but I also wanted to point out what would be the proper way to expand upon this. Okay, so here we have our very basic custom action class that is set up to execute two different action types. Now let's go back into the editor, and in here let's make a game object to run our script, call it our custom action, and let's drag our script onto it. And yep, right away we see our issue. Now this one, for example, we just want it to be a chat bubble action, but we're also seeing the move parameters. So this is where a custom inspector comes in. We can use some logic to show or hide parameters. So when we select on this enum the chat bubble, we only want this one to show and we want this one to be invisible. And same thing, select the other one, hide this one, show this one. Okay, so let's make our custom inspector. Now for that, first we need to make a folder. So down here, inside the scripts folder, let's create a new folder, and this will be our editor folder. And inside this folder, we're going to add our editor scripts. So for our custom inspector, let's give it the same name and add editor at the end. So in C# script, call this the custom action editor. All right, let's open it. Now here, the first thing we need to do is add up here, add using Unity editor. This is so we can use editor classes. And in here, instead of extending model behavior, we're going to extend editor and get rid of these two. All right. So this is the base class for custom editor script. And now in order to make this a custom editor of our script, up here we add the attribute custom editor. Then we pass in the type of, and we pass in our actual type. So in this case, the custom action. So this means that this script will be applied as a custom inspector whenever we inspect a class of type custom action. And now in order to showcase a custom inspector, we need to add the override. We override on inspector GUI. And if we just save this and go back into the editor, yep, right away our custom inspector no longer shows the default representation. So right now it's not showing anything since we didn't tell it to show anything. Alright, so with this starting point, we can now choose exactly what we want to show. So here in this function is where we're going to build our custom inspector. Now the underlying data for our script is in a serialized object. So we access the field serialized object. And the first thing we do is update the representation of our object. So we call update. And now we can decide to show a specific property. So the way we do that is use the editor GUI layout. And we can create a default property field. And in here we pass in the property. So once again, we access the serialized object, we find the property, and we give it our type. So in this case, we can go back into the action, and let's just show the action type. So let's pass in this. So just like this, we should see the inspector displaying our type. And this function automatically identifies the type of the property. So in this case, since it's an enum, it will show the standard drop-down menu. So we do this, and at the end of the uninspector GUI, we need to call our serialized object and call apply modified properties. So this writes any changes we make back onto the underlying object. All right, so that's it. This is the absolute basics for making a custom inspector. And if we test, and yep, there's the custom editor script running. It is showing exactly just the type field, which is what we wanted. All right, great. So now that we have this working, let's show the remaining fields whilst also applying some logic. So for our logic, we need to apply a switch on the current selected type. Now the current selected object is stored within target. So this is the object being inspected. And we can cast this down onto our custom type, which is custom action. So here we have a reference to our selected instance. And now here we can do a simple switch. We access the action type. And then let's do a simple case. So if we are on chat bubble, then let's show the chat bubble params. So we do the exact same thing. In this case, again, go back and use the exact same name, chat bubble params. And we show this one. And in case the other one, we show the other. All right, that should do it. Back into the editor. And yep, right away we can see it working. So if I select the chat bubble, it shows the chat bubble params, and if I select move, it shows the move params. So the inspector is only showing exactly what I need based on the type that I select. Right, great. So just like this, we already have built a custom smart inspector that only shows exactly what we want. So this is the simplest custom inspector that we can build. And here, since we have access to the underlying object, you can do whatever you want with the inspector. For example, let's say we want to add an extra button over here on the chat bubble. So we go into the GUI and layout in order to create a button, and let's call it button, and just like that. And yep, there it is. If we select the chat bubble, we see our nice button. Even if we select move, we do not see it. And right now we're showing the entire chat bubble params, but we can also show each field individually. So to do that, instead of showing the serialized object of the chat bubble params, instead we do this. We go into that, and then we actually find the property relative to that one. So in this case, chat bubble params has these parameters, and let's say we just want to show the text. So we just show that one, and yep, there it is. If we select chat bubble, we see our button and our text field. So just like that, you can see how extensible this system is. All right, so this pretty much covers the basic custom inspector. Now let's add some gizmos over here on our scene view. Now for this one, there are two places we can write our code. Over here in the editor script, we can add the function public void on scene GUI. So this function gets called whenever the scene updates. So here, for example, let's draw a simple text label. All right, so just like this, we should be able to see some text showing the action type right on top of the custom action transform. And yep, we see it right there. There you go, the chat bubble highlighted right on the object. So just like this, we can visually look into the scene view and immediately see, all right, this is a chat bubble. However, the onScene GUI method only runs when the object is selected. So if I select something else, yep, there you go, the label actually disappears. So if we want to display some information at all times, then this is not the best approach. Now, the other approach we have for drawing gizmos is on the normal object script. So here we are on the custom action script, and let's go down here. And what we can add is a simple private void on draw gizmos. So this one gets updated whether the object is selected or not. So here we can add the same code. All right, just like that. Let's test. And yep, there's the text label. So I can select it, and yep, it's there. Select another object, and yep, it's still in there. So this label now shows up whether the object is selected or deselected. Now in this case, I want to show some information at all times, so let's go with this approach. Now there are actually several ways of drawing gizmos. So for example, for drawing a simple line, you can use the handles. Then you also have gizmos.drawLine. And then you also have the debug.drawLine. So all three methods behave in the exact same way. So here in the editor, we can see a line going from the object position onto the origin. Now I've tried to look for what is the difference between all of them and which one should be used, but I couldn't really find anything. So if you know how they differ from each other, then please let me know in the comments. Now, the one difference that I see is that handles exist inside of Unity Editor, whereas Gizmos exists inside of Unity Engine. Now, in this case, I will be mainly using handles since it has a lot more options than Gizmos. And the handles works both in here and also over here on the editor code, whereas Gizmos cannot be used on the onScene GUI function. And since handles uses the Unity editor, let's go up here to add a using statement. And let's also add an if to make sure that this code only runs in the editor and not in a build. Alright, that should do it. So let's draw some lines between all of our fields. Now this code here is running on this object, so we can access all of the fields up here. Let's start off simple by drawing a line when the chat bubble type is pointing to our unit. So we do a switch on our type. Alright, so here it is. We do a switch on the action type. If we are on the chat bubble, the first thing we do is we check if the game object field has been set, and if so, then we draw a line going from this onto the object position. So very basic, very simple. Let's see. So here we are, and right now, yep, there's no line pointing anywhere since that field is set to null. And now let's say I drag reference to this unit, put it in there, and yep, there you go, now we see our nice line. So you can see that this event is correctly linked onto that unit. So we can very easily visualize all the links to our actions. Awesome. Alright, now let's apply the same thing to our move type. So here we just do a switch on the other type. Alright, so doing pretty much the same thing. First we test if we have something set to that field. If so, we draw a line from the action onto the unit game object. Then we draw another one from the unit game object to its move position. And this one, just for fun, we're adding a different color. Let's see how this works. So here we swap the chat bubble for a move, and there you go, that link disappears. Now let's drag our reference, and yep, there it is, and it's going on to move position 000, so right there. So we can move this, and yep, there you go, the line is moving. So without any object selected, I can just look at my scene and see that over here I have a move action. It's connected to this unit, and it's going to move this unit from this position onto this position. And since we're working with a custom inspector, we can very easily add a custom handle to this vector3. So back into our custom action editor script, in here we can add a position handle. So before all of this, let's begin to add a change check. So that means that the code over here in the middle will be checked if it changes or not. So it's in here that we can add our position handle. So we go into the handles and we create a new position handle. So we add a position handle right on the move params move position. And now this function returns the new target position. And this one returns true if something has changed. So if it has changed, then let's modify it. Alright, so like this. Now here the position handle cannot actually be used whilst inside of the onInspector GUI, but rather it needs to be used on the onScene GUI. So let's pass this code in here. And again, this one is for the move parameters. So let's do a switch on our type. Alright, there it is. So if we have the move type, let's show a move position handle to update our move position. Let's see if it works. So here we are and select our object, and yep, there you go, now we have a second move position handle. So we have this one for the actual object position, and then we have this one to modify the very nice move position. So instead of setting numbers in there, we can use this really nice handle. Right, awesome. And here, let's just make this the complete proper way, so let's also add an undo. So we record the object state, then we change it, and we update the serialized object. So here we are, and now if we move it and we press Ctrl Z, yep, there you go, we have the nice undo. All right, great. So we've already learned how to make a custom inspector and add some custom gizmos. Now, just for fun, let's see how easy it is to add a new action type. So let's expand upon our custom actions. Let's add a door action. And once again, down here, let's make the parameters. Alright, so there it is. Over here we have the new Enum type. Then down here we made some new params, added all of the required parameters and the function to execute this action. Then down here we added to our switch. Now in the editor, let's show our property fields. There it is. And on the gizmos, let's show some gizmos. Alright, just like this. Alright, so now back in here, we can swap this from move and select door. And there we have our door parameters. So here, let's pass in this door reference and let's tell it to open. And now let's just make a script to run our very first action. Here it is, a very simple script. We just have a reference for our starting action, and on start we execute it. And here it's just set to this object and we're going to run this action. So we should be able to play the game and see the door open. And yep, there it is, we saw our action and our door open. Awesome! So you can see how easy it is to expand upon our system. Now if you want to know more about this door, it was actually fully created on a previous video. I've done 3 videos covering doors, one on the key door system, one on various methods of creating doors, and one on various ways to interact with any object. So if you want to learn more about how the door is made, then check those out. Alright, so we have our inspectors and our gizmos. Now let me just polish this up a bit. Alright, so here it is. I made this nice function to draw some cool arrows. It's using the draw AA polyline in order to draw a nicer anti-alias line. It also supports drawing in different colors. There's a label right down the middle saying some text, and a bunch of lines to make it look like an actual arrow. Let's see it in the editor. And yep, there it is. So we have some very nice arrows pointing to our targets with some labels providing more context. So just by looking at the scene view, we can see all the information to understand what is going on. So this is a door type, and it's pointing and it's linked towards this door, and it's going to make it open. Alright, now let's just build the scenario that we saw in the beginning. Alright, so here it is. I just set all the fields and we can very easily see what is happening. So it's going to start off with this move action. So it's going to move this unit onto this position. Then once he reaches there, he's going to go into this next action. This is the door. It will open this door. When door opens, then he moves on to this one, which will move this unit back into this position. Then when it does, it triggers this chat bubble. So this unit will say this message. Then it goes into this one where this unit goes there, and then it goes into this chat bubble where he says something. And then it goes into the move, which is going to move that one all the way back up there. And then finally closes the door. So we can very easily visualize all of our scripted behavior thanks to all of our very nice gizmos. Let's see it in action. Okay, there he is. He goes in there, he opens the door, he moves forward, he says his message. Then the other one moves forward, says his message. Then he moves away, and finally he closes the door. Alright, awesome! So here we have a really nice scripted scene that we built using our very awesome new easy to use tool. We have our custom inspector just showing the parameters that we need, and we have a whole bunch of information on our scene view to easily visualize what is going on. Again, this is just one possible example of the benefits of writing a custom editor with custom gizmos. You can apply this to whatever you want in your games. So, before you start manually creating tons of content, ask yourself if you can spend just one day building a tool that will greatly improve your productivity. Now in the next video, I will cover how to capture clicks in the scene view in order to take this tool even further. If you're watching this in the future, check the link in the description, and if not, it should be out by next week. Check out the CodeMonkey app on Steam. Interactive tutorials, complete games, and more. Click the link in the description and add it to your wishlist. This video is made possible thanks to these awesome supporters. Go to patreon.com/UnityCodeMonkey to get some perks and help keep the videos free for everyone. As always, you can download the project files and utilities from UnityCodeMonkey.com. Subscribe to the channel for more Unity tutorials, post any questions, have in the comments, and I'll see you next time.